DNA recovered from fired shell casings can be used to tie a suspect to the scene of a shooting. But often, forensic laboratories do not process shell casings for DNA evidence because traditional analysis methods have a low success rate due to contamination, DNA degradation, and PCR inhibition. Signature Science's proprietary DNA extraction method, FRISC, maximizes DNA recovery from fired shell casings. While some shell casings may not hold any DNA due to the way they were handled or loaded, those that do are invaluable pieces of evidence for investigators. FRISC is optimized to collect the maximum amount of DNA from the surface of the casing while maintaining the highest possible DNA quality, which, in turn, leads to the generation of more complete DNA profiles for comparison. Our DNA casework analysts are using FRISC to generate DNA profiles that have been uploaded to CODIS and are leading to convictions. Signature Science conducted an internal study to characterize FRISC's collection and extraction efficiency from fired shell casings in controlled settings. 3 separate donors deposited fingerprints on 9mm brass cartridges. The shells were fired, and the casings were collected. In the laboratory, the fired shell casings were processed for DNA. The validated FRISC method was compared to a conventional swab extraction approach. DNA quantity, quality, and STR profile metrics were obtained for each sample. The results demonstrated that FRISC outperforms a conventional swab method, with higher average DNA yield and lower overall DNA degradation. Critically, the FRISC method enabled the generation of CODIS-eligible profiles 38% of the time, with nearly 50% of profiles suitable for single-source comparison. FRISC routinely outperforms conventional methods in terms of DNA quality and total profile alleles detected. Building upon the success of FRISC, Signature Science's Center for Advanced Genomics research team is currently developing improvements to the extraction method. The objectives are to streamline the handling of the shell casing, minimize inhibition and degradation caused by gunpowder residue, decrease reagent usage, and reduce the overall processing time. In an internal study, human fingerprints, as well as specially formulated artificial fingerprints optimized for use on brass, were added to individual previously fired shell casings. Our data shows that with the method improvements, we can recover 40% of the total DNA deposited in the artificial prints, and an average of nearly 1 nanogram of DNA from human donors.